This lecture is about predicting models with input. In the case of an Armax process, you also have an input component here, b times x, where the input signal is delayed d steps like this. To form this prediction, you start by a trick. You say that y is equal to y, but then you do c divided by c. Then you recall that c divided by a we expressed as f plus z plus minus k g divided by a before, meaning that I can write the top c like this. I then move the k plus 1 in here so that I remove the c to the minus k here, so I got this expression. Next I note that a times y I can express like this, allowing me to replace ay by this. Notice that I again now have a polynomial division, fb divided by c instead. I can write that as the part that I can divide. I denote that f hat, and then there will be a remainder. I call that g hat now. And I can get those by solving this new Diophantine equation, which says that fb divided by c should be the f and g divided by c like this. The order of these polynomials will be k minus 1 just as before, but the order of the g polynomial will change like this. Inserting this gives me this expression for the future, where of course I will have two components that depends on the future values, both of the noises and the inputs. The future inputs I might be able to determine, whereas the future noises of course I cannot do much about. Adding the conditional expectation to give me the prediction, I will have the term of predicting the future noises, which of course then will be 0, but then I will have the term predicting the future inputs, which I then typically can build a model for and do a prediction for. The result will be this expression. The prediction error will be then the component that I couldn't describe of the future noises and the part I cannot describe of the future inputs in case I couldn't do that. So for example, if I have this polynomial, this would be my a part, this would be my c part, and this would be my b polynomial. Notice that I have a delay of 4, so in MATLAB I would write that as 4 additional zeros in the beginning. I form the polynomial multiplication by using the conv operation. That will be the equivalent in MATLAB, and then I do the polynomial division using polydiv. A common source for confusion is what I mean when I say that I should do a k-step prediction like we now have. Say that I have a sequence like this, and I form this is my time t, and I want to do a 3-step prediction like this. I want to find this number. The true values are of course known since I'm working on my validation set, so I have these number here, right? So if I want to form the prediction, I can form the prediction error as the difference between these two. However, that only gives me one prediction error value. So what I do now is, of course, I shift my data one step, like this, now assuming that I have t plus 1 as being known, making a prediction of t plus 4 instead. Of course, I still have the future, allowing me to form now the 3-step prediction for this value. Then what I do is I shift the time again. Of course, I still have the future, and can form the 3-step prediction error again here. This allows me to form a 3-step prediction error throughout my sequence by shifting my data that I assume to be known one step at a time all the time. So this is what I mean when I say that I will compute the prediction error. Proceeding, we will look at the Box-Jenkins process instead. This would just be a special case of the Armax process. So basically I will just rewrite my Box-Jenkins model on an Armax form like this. To simplify my notation, I will introduce the new polynomials ka, kb, and kc like this, and now I have a new Armax built from these like this. If I follow exactly the same steps as I did before for an Armax process, I will get the same kind of polynomial division, but now I will have new polynomials, and I have a new Diophantine equation, which of course then contains the new polynomials, and the orders will of course then be slightly changed as well, giving the expression for the future value like this, and of course I cannot predict the future inputs, and this will therefore form my k plus 1 prediction of a Box-Jenkins model.